Hello everyone, this is Dr. Dibbas Dibora presenting you the lecture series on quantum computing, and this is the first lecture in this series. So in this lecture, basically we'll deal with what actually it meant by quantum and quantum computing and some history regarding this. So let's start the class. First of all, what is a quantum computer, right? So I hope you already heard about this quantum and quantum kind of things. So now, what actually a quantum computer mean to you? A quantum computer is a machine that performs calculations based on the laws of quantum mechanics, and that is the behavior of particles at the subatomic level. Well, now actually we can define this quantum computer as that computer where we perform the calculation based on the quantum mechanics laws. And if we go into the specific definition of it, then quantum computer relies on some special memory that is known as quantum bit to perform parallel computing, and that is to a massive one. Okay, this means a very faster one. So this is the definition. Now, this image, if you already heard about the quantum computing, I know that you already got this type of images in your Google search or whatever the search engine you are using. So you see this quantum computer looks like this. Can you tell me from where you will get this image actually, and means what this image is describing it to you? Now, first try to know what actually quantum. We are consistently using the word quantum computing, right? We also know that now from the definition that quantum computer is that computer which is performing its calculations on the based on the laws of the quantum mechanics. But actually, what is quantum mean to you? Can you define it? Can you answer this? Well, let me give the answer for you. In physics, actually, the quantum is the minimum amount of any physical entity that may be a physical property too involved in an interaction. So quantum is the minimal amount of any physical entity, right? Now, let me clear this. The fundamental notion that a physical property can be quantized is referred as the hypothesis of quantization. And what it means? This means that the magnitude of the physical property can take on only discrete values consisting of integer multiples of one quantum only. So it is considering only discrete values, and that may be a multiple, integer multiples of one quantum. Okay. So now, if you cite an example, you know about photon, right? Photon, light, these things you frequently use in your physics class, right? So this photon is a single quantum of light or any other form of electromagnetic radiation. So photon is an example of our quantum. Similarly, the energy of an electron bound within an atom is quantized and can exist only in certain discrete values. To remember, whenever I am trying to define this quantum on quantum computation, I am using this word discretization to note it. Now, let's have some history regarding this quantum computation. So for that, we'll start with one quotation that is by Feynman. I think I can safely say that nobody understands quantum mechanics. This is a very, you know, popular quote by Feynman. Now, who is this guy? Do you know about him? Okay, let me give you the introduction of him. This is Richard Feynman, a popular name in the quantum mechanics. Now, he is actually the full name is Richard Phillips Feynman, and he was an American theoretical physicist known for his work in the path integral formulation of quantum mechanics, the theory of quantum electrodynamics, the physics of the superfluidity of supercooled liquid helium, as well as his work in particle physics for which he proposed the quantum model. But you have to know him because of this contribution by him in bold. And what is that? For contribution to the development of quantum electrodynamics. Feynman received the Nobel Prize in Physics in 1965 jointly with Julian Swinger and this Tomonga. Okay, so this is why we know him. Now, in 1982, Feynman proposed the idea of creating machines based on the laws of quantum mechanics instead of the laws of classical physics. So he actually worked in the area of theoretical physics. He tried his best to define or means introduce the terms in quantum mechanics. And in 1982, he proposed the idea of creating machines based on the laws of quantum mechanics rather than the laws of classical physics. So this is the first history regarding this quantum computation field. Now, some more development in this area we can see is, let me clear this. First, in 1985, David Deutsch developed the quantum Turing machine, showing that quantum circuits are universal. This is also very great development in this field. And about this Turing machine, we'll discuss this in our next lecture. In 1994, Peter Shor came up with a quantum algorithm to factor very large number in polynomial line. And this algorithm, today we are using in the area of quantum cryptography, famously known as Shor's algorithm. Then in 1997, Love Grover develops a quantum search algorithm which has the complexity of big O of square root n. These three developments we cannot ignore in this area of quantum computation. In fact, I can say that these are the actually the roots behind this quantum computation. Now, in recent days, you know that IBM has been one among the top tech giants who is providing quantum services. So this is all about today's lecture. And in today's lecture, we try to know what is actually quantum computation or quantum computer, and then what is quantum, and then some history about this quantum computation. As this is an introduction class, so we are going to uh, close this session for it for this lecture. But in the next lecture, we'll come with some important topics. In fact, in that lecture, I'll try to discuss about that Turing thesis regarding this quantum computations. Now, yes, wait, please, because you have to answer questions that I will ask in every lecture. And for today, these two questions are for you. First question is, what do you mean by quantum? Define from your own sense. Okay, what actually quantum mean to you? Then second, you need to state either true or false. And the statement is Grover's algorithm is a quantum algorithm for searching an unsorted database of n entries in V go of square root of n time. You need to say true or false. So do comment the answer and I'll check them, no doubt. So with this, Dr. Dibboy is signing out for today. Thank you. Take care. We'll meet in the next lecture. Bye bye.